Good morning, Dr. Mitch and friends. Today, our group is going to talk about design and fabrication for milk products packaging. My name is Devin, and I hope you guys enjoy our presentation. So here is the brief outline of our presentation today. We are going to explain the packaging we choose based on the product and three packaging types, which are primary, secondary, and tertiary packaging. Furthermore, the fabrication of these three steps packaging design will also be explained in detail. First, we're going to start with introduction objectives. So, for the food and beverages products, we are going to choose dairy product, which is milk. And based on the product chosen, our group choose paper-based packaging based on several reasons that we'll explain in future slides. First of all, I'm going to explain about the characteristic of the paper-based packaging. First, paper has a low strength to weight characteristic comparing to other packaging materials. Second, it has a low density materials which make papers considered as a lightweight materials. The third is paper are also easily decorated and designed, or in other words, versatile. It is very customizable to meet product or customer specific needs. Paper is also very recyclable, so it is very good to use paper for the environment. Last but not least, from the previous characteristic, which is lightweight, low density, versatile, and easy to be packed, these all conclude that paper-based packaging is also cost efficient in transportation. Next is the type of paper packaging paperboard. First is uncoated recycled boxboard. It has a low-grade recycled fibers with poor bending characteristics and is usually used for setup boxes and partitions. Second one is white-lined chipboard. Chipboard is usually the lowest quality and cheapest paperboard. It is usually used for cereals, dried foods, crackers, and detergent. Third is solid bleached board, usually used for milk, juices, soft drink, and it is very safe for food product direct contact. And the fourth is solid unbleached board. It has high stiffness and good wet strength. It is used for powdered detergent, electronics, sporting goods, 12-pack beverages, and carriers. Last but not least is FBB, which is folding box board. It has a high stiffness and smooth surface, usually used for packaging for frozen and chilled food, biscuits, and also bakery products. After talking about the characteristic and type of paper-based packaging paperboard itself, next is the design of the packaging container. First is basic tube style. It's basically has an open-ended tube design, which is very simple design. And the second is top closure. It has a reverse stock on both sides, so we can have an opening on the upper and bottom side. Third is a gable top. The design is usually used for the dairy products and fruit drinks. Third is basic tray style, usually used for simple food in a restaurant and takeaway place. Next one is bright wood tray. It have the enclosing and good for shipping and merchandising. Last but not least is a beverage basket and setup containers. From all the design above, based on our product, which is dairy milk, our group will choose gable top as it is the most used worldwide and appropriate according to the design and enclosings.
Now our group would like to tell a little bit more about the concepts behind the primary packaging of the milk products. Let's start with the materials. The base of the carton itself is made of the mixture of the hardwood and softwood in 6:4 ratio, coated by the waterproof plastic, usually polyethylene, as well as some chemicals for coloring and strengthening. Let's proceed into the fabrication methods used in manufacturing the carton boxes. The procedure starts at the Fourier machine, where the refined fiber pulp is soaked in water and dried into a carbon sheet. Then, thin film of the molten polyethylene coming from the extruder is applied to the freshly produced paperboard. After that, the chilled sheets of the waterproof paperboard are woven into large rolls and transported further. Continuing with the procedures of the fabrication, the wounded rolls are transported to the printing area. Printing is done by the flexographic method, where the rubber printing plate is attached to the steel sheet. The mentioned press paints and cuts the blanks to send them to dairies. At the dairies, next step includes using a forming machine and its mandrels to open the boxes and seal the bottoms of the containers. After that, filling machine nearby pours milk into newly sealed cartons, passing them through the conveyor to the top sealing machine, where the tops are being folded and sealed, and the packaging is ready to be processed further.
In the economic point of view, the production of paper-based packaging is relatively cheaper than its competitors, which are glass and plastic. As the growth market of food milk processing industry has been positively growing, it is found that the consumers' demand for an inexpensive and high-quality milk product in a convenient packaging is also increasing. Therefore, producers have been innovating such milk packaging with affordable price and come up with a gable-top paper-based packaging. This idea is undoubtedly reducing the manufacturing cost as the production fabrication is found to be less complex and the accuracy of filling the gable-top paper-based packaging is higher than glass and plastics. Subsequently, the current gable-top paperboard cartons used for milk packaging is designed with additional ESL packaging or extended shelf life packaging to prolong the shelf life of milk while reducing the risk of contamination from physical, chemical, and biological sources. Hence, this packaging is relatively suitable for milk packaging and it is generally lightweight compared to plastic and glass, so it becomes the main advantage in the distribution point of view. Moving on, this type of milk packaging is yet considered to be environmentally friendly because the paper-based packaging is usually laminated with plastic called polyethylene. This combination makes the production fabrication of this type of packaging consumes high energy and generates more waste, as it is not really appropriate to be recycled again and used as the primary packaging. The last point is related to marketing and design requirement. The main advantages of paperboard cartons are usually linked to its simplicity to create personalized design for the packaging. Hence, it makes a good impression for brands in terms of its marketing. However, the current milk packaging is not particularly easy to open and quite difficult to be reclosed. Based on the discussion mentioned before, some suggestions could be proposed to enhance the quality of gable-top paper-based packaging. So the first suggestion is to provide paper straw inside the milk packaging as shown in the figure. This suggestion is made to improve the easiness in drinking the single-serve milk. So for the larger size milk, the round lid will be added to enhance the opening and reclosing process. This suggestion does not only aim to create better efficiency, but also to prolong the shelf life of milk itself. The second suggestion is to design the overall packaging using polyethylene-based material. As mentioned before, the current gable-top carton glazed by a waterproof plastic is not appropriate to be recycled. Therefore, it is suggested to change the use of paper-based to fully polyethylene materials as it can be fully recycled. Moreover, it is found that the production fabrication of polyethylene is now using sugar cane as the fuel, so it generates less emission and uses less energy. Additionally, the packaging will be equipped with some technological input, which is heat sensing codes to indicate the spoilage in the milk. So the milk will change to brighter or darker colors when the pH of milk is changing.
It's time for secondary packaging, which is also very essential among those three types of packaging. Let's talk about what is secondary packaging first. According to McGuinness, secondary packaging is the exterior one of the primary packaging, and there are few functions and requirements related to this type of packaging. With the first one, grouping packages. It allows a number of primary packaging to assemble together. Then, it also provides the ease of handling, which facilitates the delivery of vast quantities of the product to the point of sales or end users. More importantly, secondary packaging can protect the primary packaging and the product itself. For example, during the transport on pallets. Last but not least, labeling and the brand name can also be shown on the design, which include the logo and company information. And the level of packaging a consumer receives first is secondary packaging. This makes the appearance of secondary packaging very important and leave the customer with the first impression. There are two features for our cardboard boxes. The first one is there will be printed image repeated on all sides except the base. Company can put their logo, their brand name, even their product pictures on our secondary packaging design, the cardboard boxes. The second feature is that there will be integrated perforation on the front sides, which after they have been removed, the cardboard boxes can be placed on the retail shelf directly. For the material part, we have decided to use the corrugated fiberboard, and it is made from the craft. There are a few characteristics for this type of material, and the first one is durable. Since corrugated fiberboard is made with 3 layers and there is a ruffled fluted material sandwiched between the inner and outer cardboard layers, it provides exceptional strength that can withstand severe wear and tear throughout the packaging, storing, shipping, and retail display process. Meanwhile, the fiberboard can easily be transformed through color, shape, and branding. For example, it is easy to be printed on, which can create generally personal packaging. The third characteristic is that it belongs to one of the eco-responsible materials. Because the corrugated fiberboard is biodegradable and contains no dyes or bleachers. Lastly, it is also lightweighted and flexible because the ruffled inner layers offers incredible strength and flexibility while keeping the overall weight of the container down.
I'm going to share the fabrication of secondary packaging of milk cartons. Here you can see the brief illustrations of the whole procedure. How a roll of corrugated cardboard can be manufactured into a floatable box with graphics and text printed on. Now we will talk about the fabrication details step by step. Starting off, the process begins by making cardboards on a corrugated line. Layers of virgin papers or fibers are the main material of the board. The layers form fluting medium and linerboard. Then they are heated and glued to form a roll of cardboard. The roll is cut into sheets by a straight knife cutting off machine in desirable dimensions for later use. After that, the flexographic printing machine is used to print graphics and text on the flat box with water ink. Automated scorer collars are used to slide the paperboard. Lines on the board are rolled with slitting blades with the same machine, so the box blank can be folded with ease after this procedure. Finally, the box is glued and sealed with glue lab unit. And this is how our corrugated box is fabricated in general.
For the discussion part, it was separated into 4 sectors: economics, environment, marketing and design, and lastly, preservation and distribution. For the economics part, there are 3 lows. The first one is low material cost, which corrugated fiberboard is relatively cheaper than other packaging materials, like plastic. Then, it is low in handling costs, because we've added the integrated perforation in the design, and after tearing it off, the boxes can be put directly on the shelf instead of putting the milk by the staff manually. The last one is low transportation cost. Cardboard is lightweight, which means that the packaging does not add too much to the weight of the product overall. With lighter packaging, it makes products easier to transport and more cost-effective owing to the save on fuel and the transportation cost. For the environment part, our secondary packaging design is eco-friendly because it is recyclable, which corrugated fiberboard is biodegradable and contains no dyes or bleaches at all. And it can also be reused over and over again, which saves you money while reducing the carbon footprint. For the preservation and distribution part, as what I've mentioned before, corrugated fiberboard is durable, which can protect the primary packaging during the transportation process. However, it is not the best option for weatherproofing because water and other types of liquid can saturate these products. Lastly, for the marketing and design part, the printed images on the sign can attract the customer's attention, and using colors as well as logos, cardboard can quickly be transformed from dual packaging into vibrant and exciting protection that makes the brand easy to identify. It also provides a connection between the customers and the company. For instance, some information like the email address, the phone number of their customer service hotline can also be printed on the boxes.
Here are some suggestions our group has come up with. The first recommendation is that green material can be used. One prime example is the grass corrugated cardboard. The main feature, T-fruit, enhances printing quality compared to the commonly used B-fruit, and improves stacking strength compared to the E-fruit. It reduces cost due to its lightweight structure. On top of that, it reduces CO2 emission with its sustainability and ease to recycle. Besides, design of perforation in different sizes is also considered. It allows good product visibility despite like stacking the products into piles in stores, and also minimizes the material required. We also think the packaging printing can tailor and alter according to the different regions, so as to attract consumers graphically.
Let's discuss about tertiary packaging. The tertiary packaging has specific purposes. It includes the protection of product during the delivery and storage, helps to deliver and maintain of many products in one packaging, make the process flow of product easier, and also save time for every step of processing. There are some types of tertiary packaging. The pallets are commonly used for transportation of large number of units of product by machines and transport equipment. The crates are used for delivering by human labor. It is designed for carrying of some units together and easy transferring. The roll cages are mostly used in storages and shops for containing of certain number of units of product and easily maintain them. They also have wheels for moving that saves time. Pallets and crates are usually made of wood, plastic or metal. Every of them can be used according to specific of product and delivery and storage requirements. Wood is the most common type of pallet, the cheapest and most easy customizable. Plastic can support more weight of the goods, durable and easy to clean. Metal is used for moving extremely heavy loads, has the longest lifetime and can be used many times. Roll cages usually made of metal because it requires solid and durable material for moving of products. Companies usually use wood pallets or plastic crates for delivering of milk products, because it is not heavy load and does require such durability material as metal.
And now it's time to talk about fabrication procedures of tertiary packaging. First of all, the manufacturing process of wooden pallets is to be discussed. First, we have to select the appropriate wood and then board and fix the pallet deck and stringers onto the surface, and 3 or more parallel pieces of timber that cross the pallet deck at the angle of 90 degrees should be cut according to the size specified. Additionally, some notches can be cut in the stringers in order to allow 2 or 4-way access to the pallet sides in order to handle it with different types of equipment. And it's to be noted that pure timber is treated under ISPM 15 international regulation in order to prevent different fungi
and pests. So the wood must be heated to a minimum of 56 degrees over 30 minutes to kill the pests and minimize the moisture content of the wood. And then for large order, more than 250 units, we assemble in the wooden pallets according to the specifications in an automatic process where different type of equipment is used. But for small orders less than 200 units, we use assembly by hand with pneumatic nailers and staplers. Secondly, let's talk about fabrication procedures of plastic pallets and crates. Actually, there are a variety of methods available for doing this, and first is a high-pressure injection molding process where we melt the plastic and material and colorant together in a container. So then the melt substance is injected into a mold where everything is clamped together under a great pressure. Second method is a structural foam molding, where polyethylene and polypropylene and nitrogen gas are injected into a mold cavity and the heat is applied to activate blowing agents, so we create a foam with a solid skin. Third is the most popular one, thermoforming, where we heat the polyethylene pellets and create a nearly liquid plastic sheet, and then pull pellets into a mold and create a vacuum form. Another way of doing this is a compression molding process where we load a two-piece mold with plastic using extruders or even sometimes manually, and then a press closes the two molds and pressure forces the plastic material into the mold cavities. The next type is a rotational molding process, where we have to load the powdered plastic into a mold and then we'll be heating it as it rotates in two perpendicular planes to each other. And the rotating method ensures that distribution and fusion of the plastic is even. And the last one we are going to talk about is a profile extrusion, which is similar to wooden pallet construction. And we have to first melt the plastic and force it through the extruder. And we wait till the plastic cools down and we cut it to the size we need. And all the separate pieces are joined together using screws, nails, glue, or head welding.
There are some points here for discussing concerning different aspects of tertiary packaging. Concerning fabrication process, wood pallet production includes ISPM 15 regulation, where special timber requires extra time and resources. So, better to use engineered wood, exempt from ISPM 15, as pests are previously destroyed by heating and cleaning. Also, every method of production has its advantages and disadvantages. One of them, high pressure injection molding manufacture, has fast cycle time, but operation costs are high, while wood pallet production requires less resources. Consider environmental impact. Carbon footprint is inevitable in both wood pallet and plastic pallet production, transportation, and use. Consider economical purpose. Tertiary packaging saves the enormous amount of expenses for companies for providing the protection and saving time. Also, made of metal and more expensive ones can be used multiple times, but many companies prefer the cheap packaging with short lifetime.
After analyzing all of the aspects of fabrication procedures, we came to the conclusion that use of the plastic pallets is more preferable than the wooden ones because, first of all, plastic pallets' lifespan is more than 10 years and also it's exempted from ISPM 15 regulation, which means that we won't be spending extra time for preventing pests and fungi. And if you refer to the graph given to you here, we can see that a plastic pallet has a longer service life, which is up to 100 cycles, where wooden pallet can be used only up to 30 times. And one more thing is that plastic is lightweight, so it will be saving transportation costs by reducing the fuel consumed, and it is more hygienic, which fits all of the milk and food transport requirements. And the manufacturing process of plastic is only a single step, so it will be saving time again. And there are some things that should be considered, is that plastic pallets cannot be repaired unlike wooden pallets. That's why we have to provide better handling conditions. And carbon footprint is inevitable. That is why recycled plastic needs to be used in production to apply zero burden approach. And the next suggestion is about the appliance of the reverse logistics. So, tertiary packaging is necessary for transportation in any production and distribution networks because of the benefits we mentioned. However, nowadays it produces a lot of packaging waste every day, and in fact, some tertiary packaging after transportation may still be in a great condition, so it can be reused and collected back for another use. However, it hasn't been well established in the companies. That is why there is a lot of waste. And recent researchers suggest that introduction of a new optimization methodology will help us in minimizing the waste and also reducing the operation cost by following and creating multi-day plans for production and distribution centers. So all of the reusable packaging will be coming back using the reverse way to the production and distribution centers again to allow the reuse of the same tertiary packagings. Here you can see the list of references we used in our work that you may be interested in. And this is the end of our presentation on different types of packaging for milk products, where we discussed the highlights of the current fabrication procedure, its drawbacks and advantages, and gave our own suggestions based on that. We hope that it was interesting for you, and thank you.